So this is the second day of the trapezoids, and we're going to do proofs with them. In terms of trapezoids, remember there's only one pair of parallel sides. Those are called the bases. The non-parallel sides are called the legs. To prove that a quadrilateral is a trapezoid, you only need to prove there's one pair of parallel sides, okay? We tend to really deal with the isosceles trapezoids more than anything else. So if you would deal with isosceles trapezoids, you need to remember that the legs are congruent, diagonals are congruent, and the base angles are congruent. So if you have to prove that something is an isosceles trapezoid, you want to prove that there's only one pair of parallel sides and the non-parallel sides are congruent. We tend to really just deal with isosceles trapezoids with our proofs. Okay, let's see what we got here. ABCD is an isosceles trapezoid, and BC and AD are parallel, but they want you to prove that NBC, and that's that top corner piece. I can move this. I can't, but NBC to the top corner is isosceles. So we've got our given statement first, and we know for sure ABCD is isosceles trap, and we know that BC is parallel to AD. So we need to do actually a couple things. The fact that we have an isosceles trapezoid, we should know for sure that these sets of base angles are congruent, as are these and these. So we could say then that angle A is congruent to angle D. And I'm actually going to number these because there's more than one angle at B. So let's maybe do this. 1, 2, and I might as well give 3 and 4 in there. Okay, and that angle 1 is congruent to angle 2. And this, oh, this is given. And this is base angles of an isosceles trapezoid are congruent. Well, notice how 3 and 4 are supplementary to 1 and 2. And if you're supplementary to congruent angles, you're going to have to be congruent as well. So you can actually put that in here, and you can say angle 1 plus angle 3 equals 180. Angle 2 plus angle 4 equals 180. And then you can say angles that form a linear pair are supplementary. And then we can talk about how angles supplementary to congruent angles are congruent. So then we can say for angle 3 is congruent to angle 4 because angles supplementary to congruent angles are congruent. And if angle 3 is congruent to angle 4, then the sides opposite them must be congruent. Therefore, you must have an isosceles triangle. So let me just kind of dump this down a little bit, give us some more room. So it turns out that NB and NC are congruent. So 5. NB is congruent to NC, and that is because in a triangle, sides opposite congruent angles are congruent. And then we can say 6, NBC triangle is isosceles because definition of isosceles, if you want, or an isosceles triangle has 2 congruent sides. This is not the only way to do this proof. This is one way to do it, and hopefully that makes sense. Okay, let's try the next proof. Next guy. Triangle ABD and trapezoid ABCE. It doesn't say, oh, we're actually trying to prove it's isosceles. You know that BD and AD are the same, so all of this is congruent to all of that. And you also know that these guys are parallel. So how can we get this bottom thing to be an isosceles trapezoid? Well, let's see what we can do. Just to kind of save myself a lot of room, I'm just going to really put the bottom given. So BD is congruent to AD, AB is parallel to CE. That's all given. I'm going to actually have the fact that we've got this big triangle here that's congruent. These guys are congruent. So then we can say angle A is congruent to angle B because in a triangle, angles opposite congruent sides are congruent. We can also say how the fact that we've got parallel lines, we should also be able to say that up here at angle C, I'm going to call them 1 and 2. 1 and 2 have to be congruent also because those are corresponding angles. Kind of going back to some old stuff with parallel lines. But we can then say angle 1 is congruent to angle 2. And then we can say parallel lines form congruent, they're not AIAs, they're congruent corresponding angles. Congruent corresponding angles. So knowing that, again, probably a couple ways to be able to do this. We could actually say, here's one thought. We could say then, well, in this triangle, let's see, CDE, we could say that CD is congruent to ED because in a triangle, sides opposite congruent angles are congruent. So now we know for sure that these guys are the same. And then maybe we can do some segment subtraction. I think that might get us there. If we take the whole minus the part, you get the other part. So let's see if we can do it like this. 5. Let me bring this thing up a little bit. Okay, so how about if we say that BD minus CD is equal to AD minus ED. And that would be equals subtracted by equals are equal. And then we could say that BD minus CD equals BC, and that AD minus ED equals AE. Let me just bring this up a little bit. And that's segment subtraction. And then by substitution, you've got BC is congruent to AE, and that's substitution. And then we know that ABCE, or ABCE is an isosceles trapezoid because an isosceles trapezoid has 2 congruent sides. Okay, that's a lot. And actually, to come to think of it, hold on. Okay, so if you actually take a look at this whole proof, you know, it turns out that we don't even need to talk about, oh, yes, we do. Yes, we do. We need to have B and A, so we've got corresponding angles. Okay, so here you go. It's kind of a long proof, 8 steps. All righty. This next proof, I believe, is pretty short. What we got going on here? Isosceles trapezoid, AB and DC are congruent, so we know that already. And then we've got the parallel lines being AD and BC. We want to prove that ADB, so we want to get into here. ADB is congruent to DAC, which is here, here, here. All right, so this actually should be pretty easy, I would think. So we've got isosceles trap with AB congruent to DC and BC parallel to AD. All right, that's all good. That's given. So there's one side. You also have reflexive on the bottom. AD is congruent to DA, and that's reflexive. And then you also know that in an isosceles trapezoid, the diagonals are congruent too. So why not then do BD is congruent to, what line is that? BDCA. And then that would be diagonals of an isosceles trap are congruent. And then you actually have the fact that those triangles are congruent by SSS. And again, this is not the only way to do this proof. You could probably have done SAS also, but let me just finish this real fast. Did I miss something? No. Okay, triangle ADB is congruent to triangle DAC because of SSS. Voila. All right. You definitely could probably have done SAS as well. The fact that you've got an isosceles trapezoid, you know, the base angles are congruent. You could have done AS that way. All right, so that's it. So hopefully you find these relatively on the easy side, especially because you guys are so good at proofs now. So good luck on the homework.